Welcome to the fourth and final program in the series Mechanical Couplings and Alignment. This program, entitled Alternative Alignment Methods, describes an alignment procedure that may be effected quickly and simply using basic tools and equipment. The primary instrument we shall be discussing is the so-called taper gauge. The taper gauge is a device made for quickly assessing the dimension of gaps between two parallel surfaces. As the name implies, the gauge is tapered from virtually zero thickness to around 4 millimeters at its thickest part. The face is calibrated with scale divisions, each small division representing 1/20th or 0.05 millimeters. To read the gauge, slip it carefully into the gap to be measured. Then, without force, allow it to become lightly gripped between the two surfaces. At the point of intersection, read off the corresponding value to the nearest visible scale line. With practice, you will be able to perform an accurate coupling alignment with the aid of a taper gauge. Let's learn how. As with all alignment procedures, perform the basic pre-alignment checks after you have eliminated any motor rocking. Establish the specified gap between the two half couplings, which, as a general rule, is around 3 millimeters, with the exception of shear-type couplings. Then square up the motor by aligning the coupling halves against the edge of a steel rule or the edge of your taper gauge. Now, as we've always done, mark both half couplings so that they can be kept in relation to each other. Next, slip the taper gauge into the top between the half couplings in order to begin assessing the axial top and bottom error. Read the scale on the taper gauge as we discussed earlier. Rotate the coupling to bring both marks to the bottom and again take a taper gauge reading. Where access or visibility is limited, use your thumb to provide a reference point. With practice, you will be able to do this accurately. Note the difference in readings and decide whether the motor must be lifted at the front or the back to correct the actual error. Apply the formula T is equal to A divided by D times CD to obtain the required shim thickness. Fit or remove the necessary shims. Reset the preliminary alignment and secure the motor's hold-down bolts. Recheck the actual top and bottom error and readjust as necessary to achieve an error of no more than 0.05 millimeters. To assess the radial top and bottom error, bring the coupling marks to the top. Using the side of the taper gauge as a straight edge, assess any gap using feeler gauges. Add or remove the necessary shim thickness at each foot to bring the top and bottom radial alignment to within 0.05 millimeters. Recheck this once the motor hold-down bolts have been secured. Let's pause for a moment for discussion on what we've covered so far.